Welcome to problem solving video 4. This one's going to involve geometry. The next two will be geometry, and that'll be the last of it for me. There's some formulas you probably should know. There's another one we're going to learn too, and that's the volume of a sphere is 4/3 pi r cubed. That's one you should probably have on your 8.5 by 11 note sheet for the final. So you don't have to memorize those, but you should know those for the problem solving problems. Now, let's jump into this one. This is a geometry problem. A water hose fills a 5-gallon bucket in 2 minutes and 15 seconds. Approximately how long will it take that hose to fill a cylindrical pool that is 15 feet in diameter, and you want the water level to be 40 inches high? Well, this tells you a volume that can be filled. 5 gallons is a volume. The volume of water and the time it takes. And the question, so it gives you information on the time for a given volume. Now we want to approximate how long it will take to fill a cylindrical pool that's 15 feet in diameter with a water level of 40 inches. So it gives us a volume. So we're looking for the time for that volume. So this volume, this is a volume of water in the pool, but it doesn't tell us the volume directly. It says that it's 15 feet in diameter and the water level is 40 inches high. So the formula for a cylinder, the volume of a cylinder is pi times the radius squared times the height. They gave us the diameter. So you know that if the diameter is 15 feet, you know the radius is half the diameter, right? So half of 15 is either 15 over 2 or 7.5 feet is the radius. Okay? 7.5 feet. And notice this is in feet, and then it gave us the height in inches. So we want all one unit for volume. If you are going to measure one dimension in feet, the other should be in feet also, or if this is in inches, this should be in inches. So the question is, which one would we want? Well, notice that it gave us 1 cubic foot is 7.48 gallons. So I'm going to convert the inches to feet because they gave us a conversion factor from cubic feet to gallons. So 40 inches, if I convert 40 inches to feet, I have to put inches in the denominator and feet in the numerator. 1 foot is 12 inches, and that reduces to, now 4 divides 40 and 12, 10 for 40, and 4 goes into 12 3 times, so that's 10/3 feet. I guess I'm just going to leave that as a fraction. I could round it off to 3.333 or something, but I'll leave it exact as a fraction like that. So the volume of water in that pool, since it's a cylindrical pool, right? We use the volume of a cylinder. We get pi times the radius squared, that's 7.5 feet squared, times 10/3 feet. Now, 7.5 feet times 7.5 feet gives you square feet, and another feet gives you cubic feet. So the answer there will be in cubic feet. So we need to take pi 7 times 7.5 squared times 10/3. We can do that all at once on the calculator. You can put, if you want, you can put 3.1416 or something to approximate pi. Again, I'm going to use pi that's on my calculator. Pi times 7.5 squared times 10 divide 3. And that is 589.004. Since we're just approximating here anyway, I'm just going to write 589, and that's cubic feet. So cubic feet's a little too far away over there. But 589 cubic feet is the approximate volume of that pool. And now you can do a proportion or a conversion to do this. If 5 gallons takes 2 minutes and 15 seconds, then you could do 409. Oh, we've got gallons here and cubic feet here. We better convert our cubic feet to gallons because we've got gallons and time here. So let's convert this to gallons. So that's 589 cubic feet. We're going to multiply that by something. Cubic feet has to be in the denominator, right? CU stands for cubic. So that's 1 cubic foot is 7.48 gallons. So when we do that calculation, we have the 589 there, times 7.48, which is not exact, but that's 4,406 gallons approximately. And so we can use a conversion, unit ratio conversion, or we can use a proportion, either way. But there's 4,406 gallons. I'm going to use a unit ratio conversion. I'm going to multiply that by this rate. Now 15 seconds, let's back up here. 2 minutes and 15 seconds. I want that to be just 1 unit. I could change it all to seconds or I could change it to minutes. Well, 15 seconds conveniently is 1/4 of a minute, right? 15 out of 60 is 1/4 of a minute, which is also 0.25 minutes. So I'm going to say that's 2.25 minutes for 5 gallons. So if I've got gallons here, I want gallons in the denominator, minutes in the numerator, 5 gallons, and that's 2.25. So my gallons are going to reduce out. I get 4,406 times 2.25 divided by 5, and that's, I'm getting 1982.7, and that should be minutes. Well, that's a lot of minutes. I'm going to convert that to hours because clearly that's just too big. So let's divide, we'll convert minutes to hours for a more reasonable unit. So that's going to be 60 minutes is 1 hour. So I'm going to divide that by 60. And that gives me, wow, that takes more than a day, 33.045 hours. I would say, 24 hours in a day, that's going to be 1 day and 9 hours to fill that big pool with a hose that's just going, it takes over 2 minutes to fill a 5-gallon bucket. That's kind of probably a slow, maybe not real fast hose. So anyway, over a day and 9 hours. It's a long time. Okay, now let's look at another problem like that. So it says, consider hauling gravel to lay a 4-inch base for paving a driveway that's 75 feet long by 24 feet wide. It says, how many truckloads would be required if the truck can only hold 3/4 of a... Now, we usually say yards with gravel and dirt and sand. They often sell by the yard or by the ton even. But usually in the industry they would say, how many yards do you need? So it's 3/4 of a yard. That's a fairly small truck. 3/4 of a yard is not very big. So, and that's cubic yards. 3/4 of a cubic yard per load. So it's a small truck. So we want they want cubic yards, and notice this unit is in inches, this is in feet, and that is in feet. In order to find out how many cubic yards we need to change those all to yards. So we're going to change 75 feet to yards first. Convert that feet to yards, and there's 3 feet in 1 yard. 24 feet to yards, again 1 yard and 3 feet. And then 4 inches to yards. Now that 1 yard is 36 inches. So this isn't too bad. Feet reduce here and we get yards. 75 divided by 3 is 25 yards. 24 divided by 3 is 8. That's 8 yards. And then our inches reduced, but 4 and 36, Well, that reduces to 1/9. That's 1/9 of a yard. So the volume that we have, now this is a rectangular solid, right? It says it's 75 by 24 by 4 inches deep. So the volume is equal to the length times the width times the height. And that length is 25 yards, the width is 8 yards, and it's 1/9 of a yard deep. So that's going to be 25 by 8 by 1/9. And that will be yards times yards times yards, which is cubic yards, or abbreviated yards cubed. Okay, so 25 times 8 times 1/9. 25 times 8, that's 200. But then times 1/9 is the same as dividing by 9, times 1 divided by 9. That's 22.2 repeating. 22.2, I'll put a bar over the 2. That's cubic yards. Now they want to know how many truckloads. It says 1 truckload holds 3/4 of a cubic yard. So I'll write that. 1 load is equal to 3/4 of a cubic yard. And we've got 22.2 repeating cubic yards. So I'm going to take that 22.2 repeating cubic yards and multiply it. And I want to get rid of yards, and I want to get how many loads that is. So if we put cubic yards here and loads here, we'll eliminate the cubic yards, and we'll get the number of loads. So that's 1 load, and that's 3/4, which we might want to put that in as 0.75. But that'll reduce the yards there. And so we'll get, I'm going to put that in. I already have the 22.2 repeating in my calculator. I'm just going to divide that. I'm going to go times 1, right, in the numerator, divided by 3/4. Now I don't want to put 3/4 in. I could put parentheses around it. It's just faster to put it in as 0.75. And that looks like it's 29.629 blah blah blah. So if you do 3/4 of a yard at a time, you're going to have to take over 29 loads. It will be 30 loads, approximately. Well, you're going to need 30 loads. You'll have to have 30 loads for that, to cover that. Okay? And that's the end of that video.